Morning again. I hope everybody is healthy and happy and you guys are having fun. And today is the 10th week. See, time flies, guys, really. It's been, we have finished 9 weeks in the spring semester. Now this is the 10th week, and overall we're gonna cover like 15-week course load. So if you don't count to this week, maybe there's only like 5 weeks left after this. All right. So you need to speed up probably in your studies, because the semester is gonna end before you know it, and then we're gonna be having finals then, and finals are dangerous and difficult, as you know. And if you cannot do good in finals, then problems are gonna start. All right. So I suggest everyone to redouble your efforts again, and then try to make this semester, try to make the best out of this semester. All right. And hopefully wish for the best, and next semester we can do we can open up the schools maybe in the future. Okay, guys. So let's continue then. Let me start up the screen sharing with you. Okay, you are seeing the screen right now. Very nice. Okay, this was the slide that we stopped last week, as I remember. Okay. And we talked about like hypothesis testing, the 5 steps of the hypothesis testing. And then now actually we're not changing the topic, but we're just changing the title a little bit to the normal distribution side. Okay. And then let's learn about the normal distribution, and then find out if we have a distribution and which is not normally distributed, what can we do? And after we do that, how can we do some of the calculations? Okay, by using the formula of the normal distribution. Okay, normal distribution is also called with the letter Z, guys. Okay, so when you see or hear something about like Z distribution, always remember that this is a normal distribution. And normal distribution, if you notice, it has equal tails around the mean. Okay, the mean would be the middle point. Okay, the mean, median, and the mode would be the same number in normal distribution. Okay, and it is symmetrical around the mean. And if you look at the distribution, and its formula, the probability density formula, is written with this simple formula, guys. Okay, very simple formula. However, the good thing in statistics is that we don't have to remember this formula at all, okay? Because for our calculations in this kind of normal distribution graphics, we have our own normal distribution tables, okay? Or we call them sometimes Z tables, all right? So the tables are already calculated, and they give us all the information. So let's continue and learn a little bit more about the properties of the normal distribution. Okay, it is a bell-shaped and asymptotic at the extremes. So asymptotic, what does that mean? It means that these tails never touches to the horizontal axis. Okay, these tails, the lines, never touches to the horizontal axis, or they touches to the horizontal axis in the minus and plus infinity. Okay, they touch to the ends in the minus and plus infinity. So that means they never touch technically. So, and also it is symmetrical around the mean, like I already told you guys. And also, since this is normal distribution, the mean, the median, and the mode, they all have the same value, which is this value, okay, the mean value, whatever it is. And it can be specified completely once the mean and the standard deviations are known. Okay, so if any kind of normal distribution, if they tell us the mean is, for example, let's talk about the midterm grades in our statistics course. Okay, and imagine that it is normally distributed, which is probably not true case, definitely, because it is always positively skewed, right? There is always like 1 or 2 students that get like high grades in every class, in every class, and you know that problem. So, but now that let's imagine that it is normally distributed, our midterm grades, okay, and and if I tell you at that time the mean score of the class, for example, let's call it like 55 is the mean value, and standard deviation is like something like 7.5. Okay, what's going on here? 7.5. So then we have all the information about the normal distribution. Just by knowing the mean and the standard deviation, we can do all the calculations that we need to do, okay, to any kind of question that you can ask us. And the area under the curve is directly proportional to the relative frequency of observations, okay? So in this kind of normal distribution graphs, we are generally calculating the area under the curve. For example, at the mean level, at the mean value, the area under the curve of, let me just take the pen here, the area under the curve here, like this area, this I'm trying to tell you about, this area is, as you can imagine, this is 0.5, right? And what about the area under the curve to the right side of the mean value? That is also 0.05. All right. Well, this doesn't look like a 5 now. It looks a little bit more 5. Okay. So that means that under the area, see, it says it is directly proportional to the relative frequency, which is 0.5 and 0.5. All right. Okay, this is like another representation of the bell curve or standard normal distribution or Z distribution, whichever you call. And by the way, this was the sorry, let me get the laser again. This is just a normal distribution, okay? And this is a standard normal distribution, okay? It's the Z distribution. When we say Z distribution, what do we mean? We mean these guys. The mean value or the mu is equal to 0 and standard deviation is equal to 1. Okay? Any kind of normal distribution, any kind of normal distribution with mu value is 0 and standard deviation is 1 is a Z distribution. Okay? Here is our mean value, 0. So what does standard deviation mean in that case? In that case, if you go here, look at it, one standard deviation to the right and one standard deviation to the left of the mean value, okay, that area includes 68.2% of the entire data points. Okay, this is always correct. This is always stable. Okay. It doesn't change. This is a constant value. And if you go 2 standard deviation to the negative side and 2 standard deviation to the positive sides, okay, then that area covers the 95.4% of the entire numbers. And same again, if you go 3 standard deviation to the negative part and 3 standard deviation to the positive side, then you get to cover, where is that from here? You get to cover almost every single data point in the distribution, 99.7%. So where is the 0.3%? It is here, this underneath here, all the way to the infinity, and this area, and all the way to the infinity is, I couldn't draw it right, and that is, they are sharing the 0.3% in both tails. Okay, so you can imagine like this is easy to understand now, and it always works this way. By the way, so any kind of, like I said, any kind of normal distribution, we can convert it into z-scores or z-distribution table, which is this, with a mu is equal 0, standard deviation is 1. For that, this is our formula. This is the conversion formula. The z equals x minus mu divided by sigma, okay, the standard deviation. So let's look at a small example here. Aluminum sheets, okay, aluminum sheets that are used to make beverage cans, okay. We are talking about like those cola cans, okay, the soda cans that you are talking, you know, like you open up like a pops, okay, those kind of cans we are talking about. They have thickness, right? They have to be in certain thickness, definitely. However, their thicknesses in thousandths of an inch, by the way, yani bir inçin binde biri olarak veriliyor, okay? The thickness of the aluminum sheets are normally distributed. So what we understand here, that the thickness of the aluminum sheets that are used to make those cans, they are not always the same, they don't have always the same thickness. So there's a small variation. However, that variation has to be small, of course, right? And that variation, they measured and they found out that it is normally distributed, okay? With a mean 10 and a standard deviation of 1.3, okay? So what is the unit? The unit is thousandths of an inch. Yani 10 bir inçin binde birinden 10 tane var. Yani bir inçin %1 kalınlığındaymış ortalama ve 1.3 binde bir inçlikte standart sapması varmış. Okay? This is what you understand here. A particular sheet is 10.8 thousandths of an inch thick. Okay? A particular sheet. Find the z-score for that particular sheet. Okay? Very simple. Now, first of all, it tells us the mean. Mean is 10. What is this? This is mu, guys. See, it tells us the standard deviation also. This is sigma also, it is sigma. And here is a particular sheet that is given 10.8. What is this? This is x. So just put all these values into this, in this z calculation formula. Here it is. The z-score would be, in that case, okay, let's get the laser again. The z-score would be then 10.8 minus 10, which is the mean, divided by 1.3, and equals to 0.62. Okay, so let's now imagine what does that mean. Where are we in the z distribution graphics? Okay, 0.62. I'm just going to go back and come here. We talked about 0.62, right? Okay, this is 0 because now we are in the z world. Okay, yani artık z dünyasındayız. Because we converted the value 10.8 to the z-score. So that means 0.62, okay? What is 0.62? It is, see, look at, this is 0.5. 0.62 would be somewhere here, okay? Right here. And if you go all the way up, şaşırtıcı bir derecede güzel çizdim yani. Bozuk olmadı. Elim gelişiyor galiba şu anda. Alright, so this is where we are, 0.62, okay? And so if I ask you, what percentage of the aluminum sheets are, they have less than the thickness of 0.62? It is very simple, right? You just have to calculate all the percentages, which is under the area of the curve, right? Under the area of the curve, right? And if I ask you any kind of question like, how many percentage of the aluminum sheets are thicker than the 10.8 thousandths of an inch thickness, then we need to calculate the area under the curve of to the right of this. 0.62 in that case. Okay, this is the idea, or how to think of the problem. Let's look at here now. Oh, by the way, in this one we have to use the Z table. Let me just try to open up the Z table, and I will share with you guys this Z table as well. Let's open the Z table. Yes, Z table is coming up. All right, where are we? We are here. Okay, let's just start. Yeah. Now it says, find the area under the normal curve to the left of Z equals 0.47. Okay, Z equals 0.47. Now, let's try to imagine what is being asked from us here, 0.47. So, we have a Z distribution. Well, my distribution is not like a Z, but imagine it's actually Z. So, this is 0, and they're asking us this value, 0.47. Okay, they were asking us to the left of 0.47. So they are asking us to calculate the area under the curve of the normal distribution curve, okay, which is to the left of 0.47. Okay, now we need to find out calculate the area here. Okay, so to do that, you have two choices. One of them is using this very simple formula, guys. Okay, if you are a mathematics genius, then this is not a big problem for you. You can find out immediately. But if your math is not good, like mine, for example, my math is not that good. So we guys use Z tables in that case. My Z score is 0.47. All I need to remember is this, and also I need to remember is this. To the left of Z distribution, so I need to show this way for you. Çünkü siz ayna görüntüsü görüyorsunuz. To the left of 0.47, okay? So now let's open up the Z table. When you look at the Z table, this is the Z table, by the way. I want to ask you a question now. Bunu görebiliyor musunuz? Bir dakika, ben bu tabloyu birazcık daha, en azından şöyle biraz geniş yapayım da belki biraz rakamlar şişman olursa daha iyi görebilirsiniz. Biraz da şöyle yükseltelim. Okay. I don't want to do that. Maybe this much. Yeah, that's good. Okay. Okay, hopefully these numbers are a little bit more visible to you guys. Now remember, our Z score was what? 0.47. Okay, first of all, there are two pages of Z table every time. One of the table is composed of the why can I not write? Okay, one sheet of paper or table is composed of the negative world, okay, negative side of the Z values, and the other page is composed of the positive Z values, okay? As you can imagine, here, this is the Z distribution, okay? This is the 0, okay, the mean value. So this is the negative side, this is the positive side, right? So that means we have one page that covers this area and the other page that covers in this area, okay? So since our value was 0.47, which was positive, right? Then in this negative world, we have no business here. So let's go to the positive side. This is the positive value. Okay, our number was 0.47. Here, look at it. It starts with 0.0, 0.1, 0.2. Oh, this is my number, 0.4. But I was going to look at 0.47. So my number would be in this line, okay? In this line here. But I am looking for 0.47. Let me just write it here again, 0.47. So how do I get this 7? Okay, just subtract 0.4 from 0.47. What do you have? 0.07. Here it is 0.01, 02, all the way here, 0.07, okay? And the intersections area is what I'm looking for, okay? The value is 0.6818, okay, 6818. What does that mean? Let's go back to the question now. My value is 0.6808, okay? This was the value. What does that mean? It means that if you draw a z distribution here, which is the zero mean value, and here is 0.47, okay? Because of the fact that, because of the type of the z table that we were using, let's go back here, okay? In the second page, we cannot understand that, but let's go to the first page. In the first page, if you notice, up here, look at up here, guys. There is a graph here. Where's my laser point? I want my laser point. Okay. Looks like it's not working. I'm afraid. Okay, I'm afraid my computer might crash. I hope it doesn't happen that way. Anyway, I cannot get the laser point for now. So look at this graph up here. This graph tells us what is this table is about. This table is about, like, it tells you when you are looking at the z normal distribution graph, and if you have a z value here, this is the z value. See, these are all the z values. Okay, let's go back again. Okay, of course, depending on the negative or positive, you might have different area for the z. And this number is the relative frequency, okay, of what? Of the whatever the z value, it tells you the area under the curve to the left of this z value, okay? Well, how do I understand that? Because this part is shaded. If you notice, this is blue, this is white. So this table, all these numbers are showing us the blue area. So that means they are giving us the area under the curve to the left of z value. So let's go back here. So this is the area under the curve to the left of z value, 0.6808. Was it what I wanted to find out also? Yes, I was supposed to find the area under the normal curve to the left of z value equals 0.47. So that means this area here, this area is 0.6808. What about this area? Just subtract it from 1. So that is 0.3192. Okay. This area also to the right of the z value equals 0.47 is 0.3192. This is the left part. Okay. It asks us the area under the normal curve. This is it. If they want the percentage, then it would be 68.08%. Okay? If they are asking percentage, it is this 68.08. If they are asking for the relative frequency, 0.6808. Okay? Either one is correct. We are doing the question correctly. All right. Let's do the calculation. Here it is. From the z table, you just find out the value. Okay? And to find out that value also, you need to know how to use the z table. And I just showed you how to use the z table for 0.47. Okay, I will ask you another question, another value now. Find out the find out the z value for what is it? 2.50. 2.50, but minus 2.50. So what does that mean? Minus 2.50. Here is, let me just look for the minus 2.5. Here it is, minus 2.5. Let me get the pen again. This is minus 2.5. And since I was looking for 2.50, right? Minus. So that means after the 5, I need to go to the first column, right? This gives us a 0. So here is my value, 0.0062, okay? Or let me ask you another one. What is the z-score? What is the area under the curve to the left of 1.11 plus 1.11? Let's go back here in the plus world. Here is 1.1. So I need another one. Here, this is another one, 11. Okay, and the intersection of those column and the row is here. Here, 0.8665. Okay, now I will ask you now a different question. What about give me such a z value that the area under the curve, let me just, well, what kind of normal distribution is that? Okay, this is normal distribution, and I'm looking for the area under the curve. Let me check. Hangisini alalım? Biz Aydın'dayız. Yes, we live in Aydın. What is the license plate of Aydın? It is 09, right? Okay, let me ask you a question about the 09. What is the z value? What is the z value? Okay, I'm looking for this z value that will give me the area under the curve to the left of a value of 0.0900. Well, if this is possible, of course. 0.0909 to the left of. I'm looking for that z value. Now, let's go to the table again. Now, of course, I cannot use the table because, well, I have to use the table backwards because now I need to look at the, well, I cannot use it. I need to look at the entire table, okay, to find out 0.09 and then find the z value based on that. Okay, let me check here. What is this? 0.95, 0.70, 0.5. Okay, so that my value is 0.09. That means I need to go to the negative side. Okay, negative side. Here it is. Where are we? At the down here is 0.47, 48, C33. Oh, here, look at that. I found my number immediately, 0.09, right? This is my value. Sorry about that. 0.09. Get that again. Well, I was looking for this value actually, 0.0900 if possible, right? But this last zero was not possible, obviously, because look at that here. Because the value I have here is 0.0901, almost equal to what I was looking for. So what is the z-score for that? Here it is, 1.3 from here. Okay, I have 0 was minus 1.3. What about the second decimal point up here? Up here is 0.04. So I just write a 4 here. Okay, so that means minus 1.34 is the z value that will divide the distribution. Okay, that will divide, this is minus 1.34 is the z value that will divide the distribution as like 0.09 and 0.91. Okay, so only like a 91% is on the right side, and only 9% is on the left side. Okay, this is the z value that we can find out. Okay, this is how you can use this z table differently. I was just trying to show you those ones. Okay. Yani bu z tablosunu nasıl farklı yollar kullanabilirsiniz? Ya z'den çıkıp percentage'i bulabilirsiniz, or I can give you a percentage value and ask for the z-score. All right, different ways. So in that case, you have to kind of travel inside the z table to find out that. All right, this was the question, that last question. Okay, let's continue. Actually, now this is a little bit different question. Look at it. It tells us, find the area under the normal curve to the right of, okay, this is interesting, to the right of z equals 1.38. Okay, z equals 1.38, but to the right of, now we are looking at to the right of z-score. Let's find out. 1.38 is our z value. This is the, again, like negative page. This is the positive page. Our value z-score was 1.38. Let's find out. This is 1.3. Okay, and I need a 0.8 also. This is a 0.8. So I have 1.38. Where are we? So let's just continue. Here it is. This is the value that I'm looking for. 91.62. Okay, 91.62. Let's write here 0.9162. However, if you remember our table nature, if we like when we have a value like 1.38, okay, it always, that graph is always gives us the area under the curve to the left of that z value. So this is that. However, the question is asking us the right. So they are asking us this value. What is that value? Very simple. 1 minus 0.9162, which is 0.0, and then what is here? 8, and then 3, and another 8. Okay, 0.0838. This is the question. This is the answer. All right. Here it is. See, let me just erase what we wrote here. Here it is. Exactly. See, it says from the z table, the area to the left of z equals 1.38 is 9162. Therefore, the area to the right is 1 minus that value, which is 0.0838. See, they did the exactly same thing that we did. This is our z-score. Here is our left area, and this is our right area. Can you do it this way? Well, since our z table is giving us the always area to the left of the z value. So, and since this is a symmetrical around the mean, so if I take this 1.38 all the way here and write here minus 1.38, so then the table would give me this area, right? And wouldn't this value be equal to 0.0838, right? It would be equal. Let's find out actually. Let's look at the minus 1.38. Okay, let's look at the minus 1.38 and then see if this is correct. Okay, this is minus, let me find out here, minus 3.38 here. Here it is. Look at that. I found the same value again. Minus 1.38. The area under the curve to the left of that z value is 0.0838. This is the number that I just calculated, right? When I was using the positive z value. So there are different kinds of like mix and match that you can do here. I know you all guys are like smart kids, and you can use this. You can use this z table in any way which is advantageous to your benefit. Okay, same like positive value, then you can take the negative value, then you directly reach the question, because they are asking to the right area. Well, in that case, since my table is showing us, giving me all the values, but to the left, then, well, if I just change this value to negative, I can directly get my number, right? All right, another one. Find the area under the normal curve. Oh, now they are asking us between z-scores 0.71 and 1.28. So what are they asking us? Let's just imagine here. Okay, this is the z curve, normal curve. It doesn't look like normal, but deal with it. So this is 0, and this is, let me just write, okay, this is the 0.71, and this is the 1.28. So they are asking us the area under the curve between these two values. Very simple, right? Well, first of all, find out the area under the curve to the left of 1.28, and then find out the area under the curve to the left of 0.71, and subtract this small value from the bigger value, right? Very simple. Here it is, like, find out this area first of all. Let me just show it this way, okay? Find out this area, and also find out this area, right? And then subtract them to find this difference between them. So my first number is 1.28. Let's go to the z table, to the positive side. 1.28. Well, we just did the question with the 1.28, so this is the 1.28. Here it is, 0.8997. I just write it immediately without forgetting it. 0.8997, which is the area for this value. Now let's find out the 0.71. Okay, 0.70. 70 is here, 71 is here. Okay, here this is because this is 1. All right, what is that? 0.7611. 7611 without forgetting 7611. Okay, 0. Just subtract them. What is it? 7 minus 1, 6. 9 minus 1, 8, right? 9 minus 6, 3. 8 minus 7, 1. Here it is. This is the area under the curve between these two z-scores. And in percentage, that is 13.86%. Okay? If they ask percentage, this is how we do it. Just multiply it by 100. All right? Now, let's show how to do that. Okay? This is what we found out. Let me just write it here one more time. 13.86. And I will try to erase those values. Look at it. They did the same thing. Here it is 0.8997, 0.711, and they subtract them here. 0.1386, 0.1386. Exactly same value that they calculated, because we know how to do that. All right. Now, okay, let's now use this z-table in a different way. What z-score corresponds, sorry, let me get that. Okay, yeah, it works here. Okay, what z-score corresponds to the 75th percentile of a normal curve. What does that mean, 75th percentile? That actually means that we are trying to find out the z-score which corresponds to the 75th percentile. That means 0.75. Okay, 7500. That is 75th percentile. Yani 75. yüzdeye denk gelen z-skorunu soruyor. 75. yüzde. O ne demek? %75 demek İngilizce. Alright. So that means since this is 75th percentile, in z-score area, we write it here. 0.75. Well, sonunu söylememiş ama onun 0 olduğunu biz biliyoruz. Alright? Because our z table has 4 digits after the decimal point. Now let's look at 0.75 and what is the z-score for that? I'm going back to the z-table. All right, let's just erase these writings here. Now we are looking for the 75 in this table, guys. See, down here is all 99, 99, 99, 99, 99. Okay, here is 90, 80, 70, 85, 77, 73. Okay, let's go here. 74, 74, 74, 75. Oh, see, there is no 7500, guys. What about down here? Well, it's impossible to be here. What I have here? I have this one. Look at it. I have two values. One of them is 7486. Other one is 7517. And both of them are almost equal distance from the 750, right? This is like 14 unit farther or shorter. This is 17 unit more. What are those z-scores? 0.67 and 68. Okay, 0.67 and 68. So that is, so I have 0.67 and I have 0.68. And one of them is about like 0.7486 and the other one was 0.7517, if I remember correctly. Yes. Well, which one should I choose? Like, should I choose this one or should I choose this one? I cannot decide because they are both like it's not like one of them is really near to 7500. Both of them are like kind of almost equal distance away from the 75. So in that case, what do? I use my mathematics lab knowledge. So I take the average value. So then add them both up, find the x value, and divide by 2. And what is that value? 0.675. And then deal with this number. Okay? In these cases, if you know that, well, with your logic, okay, if you know that the number from the table is not good enough, then try to find the best one. Okay? Imagine if I give you this as an answer, would that be 100% correct? No. If I give you this as an answer, 68, would that be 100% correct? No. What about, well, if I give you this number, would that be 100% correct? No, either. Why? Because this is like 14 units shorter, this is 17 units higher. They're not, if they were like equal, then I would be kind of like, well, maybe it is. But I know that this value is closer to the 75th value than any of these two, right? This is a better value. It is not perfect value, but it is the best. It is better than any one of these two values. This is better, right? We can find out. So the other question is here. What about the 25th percentile? What is that? It is 25th percentile. What is 25th percentile? 25th percentile is exactly like this symmetrical value of the 75th percentile, right? Here it is. Look at that. This is the normal distribution. This is the zero value. 75th percentile here. This because this area under the curve is 75th, right? This is, let's write here like 0.75th percentile. And 25th percentile would be here, right? Because we are looking at this area. This is the 0.25. And here this is the 0.75. Then they should be equally distant away from the zero. If this was like 1. I can't remember. Oh yeah, now I remember. 0.675. Well, this would be the minus 0.675. Correct? Eğer bu doğruysa, bu da doğru. Because this distribution is symmetrical around the mean. All right? Now, let me just erase everything. And now they are asking us, what about the median? Median means What does the median? Well, median is impossible to find out, but we know that in this question, in this normal distribution, mean, median, and mode, all three of them are equal. So when they ask us median, they're asking us the mean, mu. Okay, what about the mu? Here it is. This is the distribution again. The mu is 0, and that gives us the 0.5 and 0.5. Okay, both tails. So what about the z-score? Z-score is 0 in that case, right? 0. This is the median. Oh, z-score is 0 for that. Here is everything. Let's find out the questions, answers. Here it is. This is the solution, by the way. You can follow it for later on and find out that exactly they are doing the same thing. Oh, by the way, what did they do here? Look at them. They were happy just by giving 67 and given minus 67. See, 0.67. But our answer was better. We gave 0.675. I believe our answer is much better than 67. Okay, our answer is much better than just writing 0.67. And the median is the z equals 0. Okay, this is very easy question, by the way. All right, I'm just going to jump this hypothesis testing. All right, now that we learned some things about the z-score, okay, how to calculate or how to use the z-table and the z-score. By the way, I will upload the z-table on the online system, by the way, okay, and Evdekal system, so you can have your z-table or your own z-table next to you, or you can go online and on the internet and search for z-table. Okay, if you search for z-table, then you can find the exactly same values that I just showed you. Okay, the table may not look like the same, but the values would be the same, okay, because there is no other way. All right, now hypothesis testing. Let's continue from the hypothesis testing from last week, if you remember. The p-value measures the rareness of an observed outcome under the assumption that the null hypothesis is true. Now, your brain is probably turning right now. What am I talking, right? We are talking about the p-value, the possibility, okay? That p-value measures the rareness of an observed outcome under the assumption that the null hypothesis is true, okay? Yani ne yapıyormuş? Eğer sıfır hipotezimiz doğruysa, bunu varsayarsak, gözlenmiş olan sonucun gerçekleşme ihtimali ya da gerçekleşme bu rareness neydi? Rare çok nadir. Gerçekleşme nadirliğini veren ifade. Okay? Eğer hipotez doğruysa, this is the definition of the p-value. All right? If the p-value is small, such as like typically p is less than 0.05, then it is often judged that the null hypothesis is unlikely to be true. Okay? Null hypothesis is unlikely to be true. Why? Because generally we choose 0.05 value as our threshold. Okay, if a possibility is less than 5%, we generally imagine that less than 5% is unlikely to happen, and if it happens, probably then the hypothesis is not true. Okay, this is the approach that we are doing. Null hypothesis is unlikely to be true because if it were, one person would not expect to have observed so unlikely an outcome. Yani ne demek burada? Şunu söylüyoruz. Eğer bir olayın gerçekleşme ihtimali %5'in altına düşerse, ya diyoruz ki en başta seçtiğimiz sıfır hipotezimiz yanlıştır. Okay? Neden yanlış diyoruz? Çünkü Eğer doğru olsaydı böyle bir olayı görme ihtimalimiz %5'in altında olacaktı ve bizim bunu böyle bir seferde pat diye karşımıza çıkması neredeyse imkansız gibi bir şey yani. Neden geri kalan %95 ihtimal gerçekleşmiyor da %5 ihtimal önümüze çıkıyor? Okey? Aradaki karşılaştırma bu aslında. Yani şöyle demeyin bana. Ama hocam biz de milli piyango bileti alıyoruz. Milyonda bir ihtimal var ama bize çıkıyor mesela. Gerçi hiçbirinize çıkmadı, onu ben de biliyorum da. Bana da çıkmadı. Çıksa burada olmazdık zaten. Orada ama orada başka bir distribution'a bakıyor. Orada her kime çıkarsa çıksın zaten herkesin milyonda bir ihtimali var. Okey. O normal distribution değil. Orada milli piyango biletinde normal distribution yok. Anladık? Yani hepimizin ihtimalleri aynı. O normal distribution değil. Alright? So, the p-value, the probability value, and the alpha level are related concepts. Okay, but there are important differences between them. Alright, alpha and p-value are related. The alpha level should be determined as a part of the process of setting up the hypothesis test. Okay, this is important. Alpha level should be determined in the process. Okay, in the process. Okay, when we are setting up the hypothesis test. Yani we determine the alpha level beforehand. That is, ne demek bu? It is a fundamental component. Fundamental ne demek? Temel. Temel bir parçasıymış. It is a fundamental component of the ground rules. Ground rules nedir? Yani ana kurallar. Ana kurallar anlamına gelir. En önemli kurallardan bir tanesi. Alright? It is a fundamental component of the ground rules established in setting up the hypothesis test. And it should be set, here, look, this is important, see, that's why we wrote it in bold. It should be set before the test. Okay, it should be set before the test is actually conducted. Yani şunu asla yapmıyoruz. Testi yap, bitir. P değeri kaç çıktı? Ya 0.06 çıktı. Ya o zaman biz alfayı yükseltelim. 0.1'e çıkaralım. Çünkü 0.05 olursa 0.06 büyük olacak. İşimize yaramaz. Biz alfayı 0.1'e çıkaralım. O zaman P değeri düşük kalır. Biz de reddederiz. Bu yapılmaz. Bu hainlikten başka bir şey değil. Okay? This is not allowed. Okay? Always we determine the alpha level in the beginning of the process. And at the end we find out the p-value and then give our answer or ne diyecektim? Kelimeyi unuttum. And give our answer. Okay? At the end. So setting the alpha level at, for example, alpha equal 0.05. Okay. Setting up the alpha level, diyelim ki alpha equals 0.05 is the way we implement the decision as to how willing we are to reject the null hypothesis as being false when it is actually true. Okay. That is, bu ne demek? Our willingness to make a type 1 error or alpha error. Yani anladık mı? 0.05'i belirtmemizin amacı neymiş? Diyoruz ki null hipotez burada, yani sıfır hipotezi gerçekten doğru bir hipotezken onun yanlış olduğuna karar verme gibi yapacağımız bir hatanın ihtimalini set ediyoruz burada. Ayarlıyoruz. Alright? 0.05. So this is the meaning of the alpha value. Yani ne kadar hata yapmaya razısın testin sonucunda. Okay? Remember, what was the alpha value? Alpha was the type 1 error which was happening because of the overconfidence, right? Because we trust ourselves too much. We trust that we know everything and we can solve this question. However, because of that overconfidence, we make a mistake. And that mistake is 5%, might be 5%. All right, this is the level of our willingness. So every time when you do a statistical test, let's say with an alpha equals 0.05, you are giving your answer that, okay, I might be wrong 5% by chance, okay, but I reject this hypothesis. Okay, you reject, and then I reject the hypothesis and say that this ve orada da en son ne dediğinizi söylüyorsunuz. Yani bütün istatistik testlerde kullandığınız alfa değeri sizin kabul ettiğiniz hata ihtimalinizi içeriyor. O yüzden zaten we want to choose a small alpha level, right? Because at the end that is our error rate if possible. Okay? Seçtiğiniz alfa sizin kabul ettiğiniz hata yapmış olma ihtimaliniz eninde sonunda. Mesela o yüzden alfayı 0.01 seçerseniz %1 verdiğiniz sonuca daha çok güvenirsiniz. Neden? Dersin bu sonuca göre hipotezi reddediyorum dersin. Neden? Çünkü hata yapmış olma ihtimalim %1. Ama %1 de olsa öyle bir ihtimal var. %5'e göre daha kendine güvenmesin. Değil mi? So setting up the alpha level therefore is important. The p-value on the other hand can be determined only after the test statistic is calculated. They are related in the sense that if alpha is 0.05, then we will reject the null hypothesis as being true if the value we calculate for p is less than 0.05. Okay? Bunları bir de kendiniz tekrar okuyunca daha iyi anlayacağınıza eminim. Mutlaka bu dersi tekrar üzerinden geçin arkadaşlar. Tekrar. Alfa ile pi'yi yerlerine oturtmak için istatistikte. Okay? So forming conclusions. Peki yaptık testi. Nasıl cevap yazacağız, değil mi? Çünkü her testin sonunda bir cümle yazmanız gerekiyor. Yani işte x equal to 25. Böyle bir şey bırakamıyorsunuz. O 25'i yazmayı, bu 25 elma mı? 25 armut mu? 25 kişi öldü mü? Bu ne 25'i? Bununla ilgili bir cümle yazmanız gerekiyor. Anlaşılır, grameri düzgün, İngilizce. Okay, in English, grammatically correct, you need to write a sentence at the end of each of your statistical tests. Okay, so to write your sentence, you need to know what you did. All right. Every hypothesis test ends with the experimenters, okay, in this case, experimenter is you or I, okay, either rejecting the null hypothesis or failing to reject the null hypothesis. If you notice here, it says rejecting the null hypothesis or failing to reject the null hypothesis. Yani şuradaki mantığı anlamamızı istiyorum. Yani biz istatistik işlemi yaparken biz burada bir bilim adamı olarak yanaşıyoruz olaya, o açıdan bakıyoruz ve bilim adamı her zaman için şüphe duyan insandır. Hiçbir zaman önüne konan bir şeyi, ne güzel, ne kadar da cuk diye oturdu, demek ki bu böyleymiş, tamam ya olsun bitsin. Asla bu yaklaşımı atın üzerinizden. Her zaman için testlere, yani sonucu bulamadım ama acaba bir hata mı yaptım da bulamadım? Ya da neden bulamadım? Yani sanki amaç şu ya burada. O sıfır hipotezini reddedeceğiz. Ne olursa olsun reddedeceğiz. Amacımız bu mantık olarak. Ama peki ya reddedemediğimiz durumlarda ne yapacağız? Kabul mü edeceğiz? No. Here it is. As strange as it may seem. Yani ne kadar tuhaf görünürse görünsün size şu anda. Okay? You never accept the null hypothesis. Okay? Hiçbir zaman sıfır hipotezini kabul etmiyoruz arkadaşlar. Okay? O yüzden sıfır hipotezine hiçbir zaman kabul edeceğimiz bir şeyi yazamayız. Yazmamamız gerekiyor. Alright? Okay? Hiçbir zaman sıfır. Mesela şunu söyleyeyim. Sınav kağıtlarınızda inşallah birileriniz sıfır hipotezini accept ettim diye yazar. Yazar da görür o sınavdan alacağı notu. Okay? You never accept the null hypothesis. All right? The best thing you can do is say about the null hypothesis that you don't have enough evidence based on the sample, okay, to reject it. Okay? The best thing you can do is you can say this way. Okay, the data doesn't support the rejection of the null hypothesis, or based on the data or based on the evidence, I cannot reject the null hypothesis. Okay, or I fail to reject the null hypothesis. Yani buradaki katı düşünce yapısını algılamanızı istiyorum. Yani hiçbir zaman mesela bunu neyle güzel örnek verelim, komik olsun da akılda kalıcı olsun. Mesela aklıma da bir şey gelmiyor ki, her zaman gelir, şimdi gelmedi. Yani ne olabilir? Hiçbir şey gelmiyor ya. Gerçekten kaldım şu anda. I can't think of anything, guys. Nothing, really. I'm like blank, empty. All right. So we either reject the null hypothesis or will fail to reject it. Yani inatçı bir itirazcı gibi düşünün kendinizi. Ya reddedeceksiniz. Ha, çok güzel oldu. Şunun gibi oldu biraz. Ergen gibi davranacağız. Hiçbir zaman kabul etmeyeceğiz. Anladık? Bakın bu güzel oldu. Tamamen bir ergen gibi davranacağız. Mesela sonuç böyle çok güzel gitti. Hayır. Reddediyorum mesela. İstemiyorum gibi mesela. Ya da şimdi istemeyeceğin kadar güzel bir şey mi? Mesela. O zaman reddetmekte başarısız oldum. Mesela annen sana çok güzel bir pantolon mu almış? Kaliteli mi? Senin de tam istediğin marka. Yine de kabul etmeyeceğim onu böyle. Kabul etmeyeceğim ama kabul etmekte şu an reddetmekte başarısızım bu pantolonu diyeceksin. Yani pantolonu asla kabul etmeyeceksiniz ama giyeceksiniz onu. Tamam mı? Sizin o. Ama yine de reddetmeye çalışacaksın. Ama sadece şu anki koşullar altında reddedemiyorum. Ama bu asla kabul ettiğim anlamına gelmiyor. Okay? Tam bir ergen psikolojisi. Güzel oldu, bu yakıştı. Alright. Okay, guys, I'm gonna probably stop here for now. Well, we didn't cover too much actually. How many weeks left? There's like 5 weeks left, and this is like let me just. These ones I left. Oh, okay, I have like 20 slides from here. Alright. Okay, most of them are questions. Okay, they are easy questions. Okay, from now on, all questions left. Okay, we can cover these questions, guys, next week. Okay, and then I'm just going to check up here. Okay, we have only like 2 more slide groups left. Okay, we can cover. We can finish up those ones. No problem. So next week we will continue. By the way, I have uploaded the slides on the system. Okay, on the Evdekal system. This slides 6 and 7. All right, about the Z table and the hypothesis testing. Okay, now this is the slide that we stopped in this case. So next week we will continue from here, guys. Okay, that's all for this week. Thank you very much. And like I said again, I really urge you guys to re-study on these slides again. This Z table, the hypothesis testing, the relationship between setting up the alpha and finding out the p-value and writing your answer based on the comparison of the alpha and p-values, okay? Or remember always to think like ergens. Ergeni İngilizce nasıl diyoruz? Yani adolescent mi diyoruz? Herhalde. Adolescent galiba. Think like adolescents always, right? Or okay, never accept anything. Always reject it. Always reject it. If you cannot reject it, then fail to reject it. But still not accept it. Okay, that is the idea of the statistical analysis. All right. That's all, guys. Thank you very much. I'm just going to stop the recording now.